Good evening, everyone. I think we can start the session now.
Shall we start now?
Yes, I think we can start this.
Okay,
Sports
okay, thank you so
48.
much. Thank you so much. So let me start my screen first.
Yeah, I'll give a small introduction and
Okay,
let's
sure.
start.
Yeah, sure. You can start.
Yes. Thank you very much, everyone, to join, and special thanks on behalf of IESL Vadakin chapter. We would like to render the thanks to Engineer Tushyantan Ponnambalam, who is graduated from University of Pennsylvania in year 2009 and complete his master's in 2012 from Singapore, and he is registered as a professional engineer in Singapore and also chartered engineer of the United Kingdom. And he is a member of the ISRA, and also he have experience of 12 years in as a professional engineer in Singapore, and he's an expert in design and engineering works in the capacity of qualified person and senior engineer and design engineer, and in all the industries like in civil, residential, institutional, and commercial engineering aspects. So we are happy to announce that we find a very good resource person for us to enhance our knowledge towards the modeling in Revit structure. So we will use this opportunity and to get our knowledge to the maximum level, and we really use this chance to thanks the resource person who give us a time and organize this event in very successful manner. And we have 56 participants who registered with us. We expect that even 55 participants can join, but up to now we have 48 participants, and we will find out. And our special thanks also, we are using this opportunity to give a special thanks for our CPD coordinator, Engineer Sergaran. So he will look after that, and also any other issues regarding the CPD, then you can straight away ask from the WhatsApp group. So we create a WhatsApp group for easy access, and also you can contact directly Engineer Sergaran, so he can give you the solutions. So, and thank you very much for everyone who will join with us. And I would like to give this session. I would like to hand over the sessions to our resource person, Engineer Dushyanthan Ponnambalam. Thank you very much.
Okay, thank you so much, Engineer Menon. Thanks for giving a brief introduction about me. Okay, before going to the presentation, I want to thank Dr. Nishantan first because he's the one first introduced to me to ISL Vadakin chapter. Thereafter, ISL Vadakin chapter contact me to conduct this course. It's a very honor for me to conduct this course to all us engineers, right? I think most of you are just graduated. Some of you already have the experience, right? But this course I mainly focus for the fresh graduate. Also, if you have say few year experience, then it's a good learning point. You can learn. Okay, so in the course basically start from basic to intermediate level. It's not up to advanced level because I want to cover the basic things. So I have only 8 weeks. So I success the course from basic to intermediate level. So okay, so later I go through the success of the course. Okay, so now is the time. Let's go to the course. Okay. Sorry, before that, Saharan, I make you as a course so you can manage the participant. Give me a minute, I make you as a course. Okay, now you can manage the participant. Let me go to the presentation. Okay, Okay, Engineer Mena already given the introduction, so I don't need to explain about me. Okay, if you want to contact me, then you can. Sahran already added me in the WhatsApp group. So if anything you want to ask me, then you can WhatsApp to here. Sometime I may not reply, but later I reply it. Sometime I may not able to reply immediately, but later I can reply it. If you want to contact me personally, later I give the email address, so you can contact me personally, right? Okay, so let me go to the presentation, right? Okay, so today's first class, right? So I'm going to explain about what is BIM. Later on, we go into the details, right? So as I said earlier, objective of this class, right? This course, right? To bridge the gap between classroom design assessment and practical design of building success. I believe all of you are familiar with the designs, right? But which we learn in the university's design classes, steel design, concrete design, all these things you already learn in the universities, right? So I don't need to go through again. If you forgot all these one, better go and review it, because I think from third or fourth week onwards, I'm going to discuss about the design things. I for up to third weeks, I discuss the software, then I go to the design. So that time you really know about the detailed designs, right? So better if you forgot about the university design classes, then go and review. So my objective is not just go through the theoretical design. So how to carry out the design in practice, right? Real day-to-day life, how we are doing the design. That's my objective. So target audience are, I believe all of you are in civil engineering graduates, so you already know familiar with their design. So that I think that's not a problem. Okay. Okay, this prerequisite is not mandatory, but but I want what I want to explain to you is you supposed to know the some basic designs. Otherwise, it's very hard to follow this course. That's why I want to put this all prerequisite thing, right? So uh, I believe all of you are very young engineers, so all of you study Euro codes, right? All time, my time, right? We have studied Euro BS codes, right? So we had to migrate to Euro codes. We had that struggle, but I think all of you are studying Euro codes, right? Then you don't have this struggle. So if you familiar with the Euro codes, especially EC2, reinforced design concrete, then it shouldn't be a problem. So if you know how to do the section design, RC section designs using Eurocode, then no problem. Okay. Secondly, when you use a Eurocode, normally we need the national annex, because not everything described in the Eurocode. You need some national annexes. Here, I'm going to cover UK national annex. Mostly we use UK national annex, right? Even we had our own Slanga one, but it's 99% similar to UK one. So I using it as UK one. It's not a problem anyway, right? There's only minor changes. Okay. The final thing is you must able to do the design by your hand, like beam section, slab section. It's no need to very complex continuous beam or continuous slab, but simple one, simply supported beams, one way slabs, so simple column. This one, the basic thing you should know. Otherwise, it's very hard to follow up this course. Okay, success of this course. How I success this course? Okay, first I do this. What is BIM? So today my focus is introduce a BIM, because it may be new to you. You may not study in universities. I don't think university cover this one, but it's BIM, because our university we don't cover the drafting part. We cover only the design part. So today I'm going to cover what is BIM, and is what is the importance of this BIM. Why we want to learn BIM. Secondly, software being actually later I explain what is BIM, because someone confused BIM and software is the same. No, BIM is a process. Later I explain. So the software is the implementation, right? Okay, like finite element. All of familiar finite element, right? If you ask finite element software, no, finite element is not a software, it's a technology, right? So it's analysis method, right? Software implementation is a software, is either ETABS or SAP 2000, whatever software is vendors doing the software, but they implement the finite element. Similarly here, right? Uh, Give me a minute. Hello. Any problem? Hello. Give me a minute. Okay, they told me my screen not share. Okay, give me a minute. Sorry. I do it. I think there's a problem. Mm, Okay, can you see the screen now? Sir, Haran, you can unmute, right?
Yeah, none.
Okay. Thanks. Sorry. I don't know. Okay, so I go back. Sorry. I go back again. Right. Sorry. I start again. Sorry about it. Uh, okay. Okay. Objective of this course, right? Bridge the gap between design assessment and practical design of success, right? I already explained this one. Just I go through because the screen not share, right? Target audience are civil engineering graduates. I believe all of you are engineering graduates, so shouldn't be a problem. Okay, pre-request. Okay, it's not a mandatory. Basically, I just want to remind you, you supposed to know these things. Then only you can easily follow up these courses. First 2-3 weeks, right? I cover up the software, then you can follow up. But later on, when I start the design, you must know these things. So if you have forgot about what you study in university, better go back and review it. Then you can follow up course easily. Okay, success of this course. Okay, today I'm going to introduce to what is BIM and what's the importance of this, why we want to learn BIM, right? Secondly, software implementation. What are the software I am going to use this BIM technology, right? So in this course, right, I mainly target Revit success, right? So there's plenty of softwares, but for easy purpose, I start with Revit because we all are familiar with Autodesk, right? When we use AutoCAD drawings, right? So be familiar with this platform. So that's why I choose in this one. So there's other softwares. If you go to the industry, some people use different softwares, but in this course, I'm going to use Revit Success. Third one is RC design. For RC design, I'm going to use Tekla Structural Designer. Okay, if you are not familiar with Tekla Structure, no problem. I will explain to you. But if you want to use other software like eTabs or Stat Pro, no problem. You can use it. I explain to you how to import to those softwares because Revit Success actually you can export to any softwares. Then explain. At that time I can explain to you how to export to the particular softwares, right? So you don't need to worry about softwares. Now, basically, what you want to learn is the technologies and design methods, how to do the design. Software just implementation. So it's just a tool. So if you know the how to do the design and how to implement it, then that's fine. Okay, so fourth one is I discuss structural framing. Okay, structural framing. To an engineer, what I suggest to you had to learn structural framing. Even you don't know softwares or you are not familiar with the software, it's fine. That's when you can learn easily. But what fundamentally you have to learn is structural framing. Okay, normally when you come to the practice, right? First day of your office, right? What you see, you see only architect drawings, right? Nobody going to advise you what is the beam size, what is the column size, or what is the slab size. But you are design classes, right? You may know someone may advise you what's the slab thickness supposed to you and so on. But here, no, you have the architect drawing only, right? From that architect drawing, how to frame the success. Okay, this one I am going to explain to you from fourth week onwards. So that's why earlier I told you, if you forgot the designs, go back and review it, then you can follow up this course easily. Okay, after we finalize finish the structural framing, then we go to the beam and develop the model, right? So how I success is first I introduce a beam, then software. Okay, how to implement this beam. Then third one is RC design software. Fourth one is structural framing, how to frame the structure. Then after we finish the structural framing, right, then we go to the BIMS software and do the modeling. Okay, for this course, right, I have chosen 5-story building. Later, I think I can share with you the AutoCAD drawings. You can try yourself also. Then in this course, I am going. My objective is all of you learn how to do the design for this 5-story building. Start from BIM model, finish the BIM model, export to the design software, do the design, then export the detail to the BIM software again, and do the construction drawing. This is my all objective of this course. Okay, so after we finish the BIM model in the Revit, then we export to the structural design software, Tekla Structural Designer, and do the RC element design, beam design, column design, slab design, right? So here the important things why we want to learn BIM. Later you will know. Okay, if you do every properly in the BIM model, right, you can export to structural design software. You don't need to do any adjustment or any modification. If you want to do the modification, it's very minor one only, just applying the load or so something only. You don't need to do any modification in the structural framing or in the geometry, right? So modification, basically what you want to do is you may need to apply the load, some loads, because some of the loads cannot apply in the Revit software, like earthquake loads. I don't think Sri Lanka we had a design for earthquake, but if you want to design for earthquake, then I think Revit cannot do it. But other than that, you can, or everything you can do in Revit. Okay, so only minor adjustment we had to do in the success software. Then the main design and detailing we are going to do in success software, because Revit have no ability to do this one. So success software, we do the design, then we do the detailing. Okay, so those already familiar design, they know what's the difference between design and detailing, right? If you are new, no worries. I explain later on what's the meaning of design, what is the meaning of detailing. So I explain later on. Okay, so after we finish the detailing, we import those detailing to BIM software, because the BIM software is ultimate one. We are going to produce our documentation, tender documentation or construction documentation, whatever document, right? Basically, our objective is whatever design you can do all fantastic design. But what is our end product? End product is our drawings, right? As an engineer, our end product is drawings, right? You can do the fantastic design, but if you cannot properly document that, it's waste, right? How you can communicate with others? There's no way, right? So the communication, right? End of the day, we are going to produce a drawing. That's our whole objective, right? So that's what we supposed to do in Revit. Then we had export, import Revit and prepare the construction drawing. Okay, so this is a overall success of the course, right? Whole 8 weeks I am going to spend on these works. Okay, these are schedules. It's important to you. You don't need to take note, because I can share it to these slides, no issues, right? So these are the schedule, how I want to go through it. Today is the introduction. Next Thursday, right? I start the Revit success, right? So I introduce the Revit success, and if I introduce some tools, how to do the modeling, right? So this modeling is take, I think, two classes, 4 hours. Then we go to the Tekla Structural Designer and familiarize that software, right? Then I think 3rd week onwards, we start the framing. So that's the actually design part, right? From the architect drawing, how to do the structural member, right? So after we finish the structural member sizing, right, then we start to do the modeling. Okay, actually this, if you look at the schedule, right, it's maybe quite rush up, because we have only 8 weeks, 16 classes, right? So I had to excuse everything within these 16 classes, right? So that's why I'll give you the drawings and the example building earlier. Then you can familiarize the building. Even if you have the knowledge how to do the structural framing, better do it early. Then when I do in the class, then you can compare. You, if you have a different opinion, just raise your hand and discuss with me, right? Okay, for easy, I mute all of you, but if you want to chat, right? Okay, I look in the chat box, right? Then you raise your hand, then I can unmute it. Okay. Okay, so this is schedule basically. Okay, then we continue. I already explained the structure of the course, right? So it is a schedule, so you can follow when we are going to do the each task, right? Okay, so I think it's a time to be go to the beam. Okay, before that, anyone want to ask anything? You can raise your hand. I can unmute you. If no, then I can go ahead. Okay, let's go. What is BIM? Okay, it stand for Building Information Modeling. That's why BIM, right? Okay, some countries people don't call BIM, people call BIM, right? It's whatever name we don't bother. So it's what is this? Building Information Modeling, right? The name itself telling us the story. Okay, building. So far, what we are doing, even AutoCAD 2D or 3D, we are drawing the lines, right? There is no any information, right? Only as engineer, we know the drafting standards, then we tell the story. Okay, this means beam, this means column, this means slab, this means doors, this means walls, right? It's based on the standard. We already set the standard. So based on standard, we are telling the story. But in beam, no, okay, beam there's a standard. Even though you don't know the standard, right? In the particular model, keep the information. What is this one? What is the function of particular object? Later I explain what is object, right? So it's basically it's object based, right? Each element is object. So object contain the information. That's why it's called BIM, Building Information Modeling. Okay. So as I said earlier, it's not a software. Actually, it's a process. It's a simple term. Later, I give a full explanation, full definitions. Okay, we don't need to remember all these definitions, but simple term is a process, right? When you do the building, right? If you want to build a building, right, there's a lot of process. So BIM is one of the process. Okay, BIM is one of the process. That's all. Give me a minute, sorry. Okay, so now we go to the actual definition, right? So okay. Yes, I read it. You don't need to remember all these. Even I also don't need to remember this one. This is just a definition only. BIM is a descriptive term for technology advanced processes in building design. Okay, it's a processes in building design. BIM is characterized by creation and use of geometrically coordinated 3D objective. So the important here is geometrically coordinated 3D object. So basically, as engineers, everything when we do the design or whatever, right, is a geometrically coordinated, right? If you want to build it, first what you do is you do the surveying, right? It's geometrically coordinate your building, right? So this model is geometrically coordinated. Then is enhanced with associated computable data, right? So that's the information. Computable data is information. Okay, data is typically integrated in 3D environment and is manipulated to describe a building project in many ways. Okay, so this is as exact definitions, right? We don't need to remember this one, but what you want to understand is being okay. This each object is geometrically coordinated. Each object contains a data. So this data is information. So information is able to manipulate easy way, right? That's the one I want to explain. Okay, why we need the beam? Okay, this curve is very famous in BIM. Why we want to do the BIM, right? So familiar with the building process, right? Uh, Building design is sort of one-time work, It's a whole building. Okay, start from normally in the design, right? We had to start when our developer purchase the land. When they purchase the land, we had to start the design until we hand over to the end user. So this whole cycle, 3-4 years, right? Whole cycle, the design is involved, right? Then main challenge is traditionally, if you want to do the AutoCAD drawings or traditional design works, right? Main challenge is maintain the changes. How, right? If we have AutoCAD drawings or manual design, manual calculation, right? How to do the changes as. So that's a challenging part, right? To easily make it this work, right? The beam come into the screen. So if we have a beam, right? But an advantage is we can do the model earlier, right? Then the downstream, our work is easy. That's why you can see in the red curve, right? So you had to do your work upfront. Then the downstream, right? Your work is less because you already have the 3D model. If you want to change it, you can change faster, right? Also, you can foresee many issues, the construction related issues you can foresee earlier, so you can coordinate earlier. So that's why we need the BIM. Okay, this is a very famous one. Those familiar construction design, construction industry, they know this one, right? Really, in the construction process, right? Our 30% of work is waste. The reason is, okay, you see AutoCAD drawings, right? Engineers, we do the AutoCAD drawings. Do you think contractors use the same drawing? No. They are going to produce another drawing for fabrications, right? A different name they use a drawings, right? So they also start from beginning. They start from beginning and do the drawings, right? So then fabricator, let's say fabricator, reinforcement fabricator, or steel contractor, they produce another drawings. So you see engineer, design engineer one drawing, main contractor another drawing, then fabricator another drawing. There's a lot of different set of drawing, but they are doing the same thing. So basically we are going to build the same building, but different people do the different drawing. Okay, level of details different is acceptable, but why we want to do the different, right? Then that's why the beam come to the play. So if you do the beam, then you can share your model. Okay, this my okay. After I finish my design, engineer design, I finish the design, I hand over the main contractor. This is my model, design model. You can develop further on for the construction. The main contractor developer until a certain level for the construction. Then he can transfer to the fabricator. See, this is my coordinated model. You can do your own trades, right? If you are reinforcement supplier, you can do your own works. If you are steel fabricator, you can use your or use for your own works, right? So there's a lot of savings in time. Everybody no need to start from beginning, so they can start from the intermediate level. So that's why the BIM model is useful and productive, right? So this is a famous chart, right? It's not I didn't produce this one. It's a famous one you can see. So after all these studies, only people understand. Yes, there's a lot of waste. There's a lot of double dribble work in construction industry to optimize and make a productive product, make it easy our life or improve the productivity, right? They come this technology that's called BIM. Okay, so now I am going to compare with the 2D rafting and BIM. What's the difference, right? So if you're not familiar, then you can understand why we in the BIM or what's the advantage in BIM, right? In the 2D drawing, I believe all of you are familiar, right? 2D drawings, just AutoCAD drawing, right? Right. So basically, you can see the lines, right? Circle, square, whatever, right? Whether it's a column or beam, slab, walls, whatever, right? Even architectural elements, right? Doors and so on, right? It's basically a line, right? So you see here, I can tell you this is a door, but so if you ask a layman, do you think they know this is a door? They don't know. They don't know it is simple. To them, it's just a simple, right? So it's 2D drafting means just lines only, right? So the layman, they could understand. Even computer cannot understand. So the BIM purpose is we make it computer to understand. That's machine to understand, right? If we make it machine to understand, then that we can use this from variety of purpose later on for BQ. If you want to produce a BQ, right? We can automate BQ. We can automate fabrications, right? I'm not sure Sri Lanka, but Singapore very common. We do it BIM. Then steel elements, right? The CNC mason can cut based on the BIM model. We don't need to do any additional process. CNC machine can cut the holes, the sizes, everything based on the BIM model. So that's the advantage of BIM. Okay, then okay, we have a 2D, then we have a 3D, right? AutoCAD 3Ds, right? So why we cannot use a 3D, right? We can use a 3D, but again, it's the lines. It won't give any information. It's just a geometry line. That's all, right? It just represents a law geometry using a lines, but there's no information. So machine cannot understand. Only human, those familiar with this element can understand. Others cannot understand. That's why we need the BIM. So the important is BIM is object-based modeling. What is object? Okay, it's like a real world object, car, lorries, whatever, right? It's like a real world object. Here is a construction object. We are talking about the construction object. Someone else talking about a different object. Let's say even construction, right? The engineer, we talk about the column beams, right? And many engineer, they talk about the fireproofing, fire alarm, pipes, ACMB, air cons, and so on, right? They use a different object, but basically all are object. The model means it's collection of object. It's okay. If you put a different object in the basket, it's called a model, right? Another important thing is an object, right? Okay. How I can explain an object? If you are familiar with the computer programming, object-oriented programming, then you can easily understand what does it mean in object, right? Even computer programming, they use this object, right? They also name the objects, right? So let's say it's a column. I use column as an object, right? So the particular column, the object, it has attributes or it's a properties. We can say in the simple term, I can say properties or parameters, right? What's the parameters of column? Length, width, concrete grade, height, right? These are the parameters, properties, I can say property. So the particular object has a property. So if I create a one object, right? The parameters are variables, right? I can change it. So I can create a thousands of instances using this object, right? Using different parameters, different properties, right? So that's the whole objective of this modeling. Actually, this start from computer programming because I think early 80s, they start object-oriented programming. So later it's come to the modeling part. So modeling people also start to do the object-based modeling because easy to maintain. We can keep the information easily. I understand. Okay, so the object basically have two basic things. First one is attributes or properties. Second is behavior. Okay, what is the function of behavior column? Is carrying the loads, right? Is carrying the vertical loads and moments, right? Similarly, what's the function of beam? Is transfer loading to the supported elements. Is a horizontal element, transfer loading sideways to the supported element, right? So each object has its own parameters and functions. So this one we can define, which can able to understand by computer. That's important, right? So that's why the beam play the major roles. So now I think you understand what's the difference between traditional AutoCAD 2D, 3D drawings and BIM, right? It's not just modeling, it's keep the information, right? So this information can be used easily, right? So later I explain how it can easily, okay, if you use a normal 2D drawing, right, it's a flat form department. That means if you do in AutoCAD, they, then you're gonna use other software to open it, right? There's a limitation, right? Even in the particular software itself, different version you can open it, but BIM is not, right? If you serve in the particular format called IFC, right? Later I explain. So you can open anywhere. It's platform independent, right? You can open anywhere. It's like a PDF. You can open anywhere. The important is you can modify it. PDF you cannot modify it, but here you can modify the informations, right? Then we don't need to depend on one vendor, right? We can use any softwares, right? So if you use all Revit, today I do the Revit, right? Tomorrow I don't want to use Revit. I can switch to another software easily. But if it's a cat, right? Lifetime I want to use a hat, right? What I can, right? Because I cannot switch. If I switch, I cannot open my previous project, So that is the particular model, right, contain the information. This information is computable, so computer can understand. So you can work independently, flat or independently. Okay. Okay. Second one is parametric modeling. Okay, parametric is I already explained parameters, properties, attributes, all are similar words, right? So why I am putting these words, because if you go to internet or if you go to any textbooks about BIM, right, mostly they use parametric modeling, right? Object-based modeling, parametric modeling, right? So that's why I want to introduce to you all these parameters, right? In the terminology, right? So the parametric modeling means again is parameter based modeling against parameters. So object contain the parameters. So you define the parameters. So particular file, digital file contain all these parameters. So how they are going to serve this information? Basically, let's say column, they give the specific name for the column. Then they define the parameters. This what is the coordinate, starting coordinate, what is the end coordinate, what is the length, what's the materials, what's the function, and so on. This is the way they are going to serve this information. Okay, that's called parametric modeling. Okay, now you can see, okay, this just extract something in the screen. Later you are going to play around it. You are going to familiar this platform. So now just see, okay, in the column, right, if you have a column here, right, so you can see the properties of the column, right? What's the diameter, right? So you can input all these parameters. Later is useful, right? Similarly, see here you can put additional informations. Okay, so whatever, so these information are useful. Later on you can easily extract it. Okay, okay, then okay, I may be faster. Okay, basically my idea is to explain about the BIM. Today is I write to finish a BIM. What is BIM, right? So later, next class onwards, I can go to the software, right? So again, this one also kind of the theory. It may be useful when you come to the practice, because sometimes people ask, what's the level of your modeling? People ask, okay, if you got internet, they are talking about 2D, 3D, 4D, 5D, 6D. And now I think they are until 70. So later I explain this, what is this, all these Ds, right? So that's why I introduce all these terminologies. Then if you go other references, then you can easily follow up. Okay, sometimes my terminology is related to Singapore industry. Mostly in Singapore, we follow US standards, right? Other countries may follow different standard. Australia and Europe, they may be different. But my terminology mostly related to Singapore. Sorry, I don't know other countries, so that's why I cannot explain. Okay. Model is earlier I said is lifetime. You have to start from day one until complete the building, right? So this whole cycle of the modeling, right? So various time. Okay, let's say when client do the okay, client cannot take the decision immediately, right? So first we had to do the SketchUp, then we had to present the client, are you okay with this model or not, and so on, right? During this discussion process, I don't need to do the all detailing, right? So before client take the decision, I don't need to do the beam design, I don't need to do the column design, right? I don't need to all, because this also all are waste of time, because client even haven't finalized his layouts, right? Then I don't need to do the all details. So the modeling has a phases, different phases. So different phases has its own naming, right? So that's why we have the different terminology. It's just a terminology, right? You don't need. Okay, later I give some definition, each terminology what does mean. So later I said, so now I introduce what is the terminology. First we call design modeling. Design modeling means there's no detail. Okay, simple term explain. In concrete building, it's just a geometry, column, beam, column size, beam size, slab size, and so on, right? There's no rebar, right? There's no any detail. It's not suitable for construction. Just a geometry, just a concrete body. That's all. That's we call design model. Okay. Secondly is a documentation modeling. So what is the meaning of documentation modeling? Okay. In documentation modeling, there's a rebar detail. Basically, this one for the tender purpose. right? When you want to go for tender, right, we had document it because it's become a legal document. For that purpose, we produce a model that's one called documentation modeling. So the third one called construction modeling. What's the difference between documentation modeling and construction? Okay, you know the difference between now design and documentation, because documentation is detail. You have a detail. That means the contractor able to price it, right? For construction work, he able to price it based on this documentation modeling. Okay, what's the difference between documentation modeling and construction modeling? Main difference is documentation modeling, designers may not think about the construction sequence, right? How to construct this one, they may not think, especially architects. They don't need to think about the construction. It's a contractor responsibility. They should come with the construction method, right? So architect to is a wall means wall. This from first order 50 stories, a wall means wall, right? So contractor is supposed to decide how he's going to divide this building and do the construction. So that time contractor add more information on the model. That's called construction model, right? So fourth one is coordination modeling. Coordination modeling means is coordinate with the different rates, right? So even construction, right? The end user may have the different requirements, right? Like services, many services, or special services. Let's say computer room, they have a server room, they have a room layout and so on, right? All these are coordinated together and put in the one model. That called coordinator model. So it's like a as-built. So it's a final product, right? But I don't call it as-built model, but it's like a as-built model. Okay, then design modeling. So what is the intent of the design modeling? Okay, so intent of the design modeling just communicate our engineer architect idea to client. Okay, just say idea. Okay, client giving the specification. So uh, I come out this framing. Okay, I come out this building, this geometry. So I explain to client, okay, this is our building going to be like this. Client earlier he don't need to know about the part of the rebar size and so on. He don't need to know about part of the foundation size and so on. Basically, he want to know how is building going to look, right? So that model only contain that information, right? So that's why you see architect emphasize on visualization rather than accuracy, right? So it may not even accurate, but it's visualize, right? So this cows look, right? Similarly, engineers, right? It's just to us just geometry. It's just do the modeling. It's not ready for analysis. Just only cover the geometry parts. So this is called design modeling. Okay, the documentation modeling, as I said earlier, is for the tender purpose, right? So we had to produce a sufficient information for costing, right? So what we do is we do the 3D model developed expressly for the purpose of 2D documentation, because documentation so far in Singapore, we haven't go into the 3D documentation. That means we haven't go into the digital documentation. Still we use a 2D documentation. That means paper-based documentation, right? For legality purpose, still we are using a paper-based document. So our contract documents still are all on the paper. So, contract documents are printed drawings, right? So end of the day, even after we do all fantastic 3D models, we had to produce a conventional 2D drawings. Okay, so far. But later, I think maybe 2025 later on, Common is thinking to quote the digital documentations. But it's still in the process. The later and in near future, they migrate to digital document, because now we are doing the modeling, everything we are doing, but end of the day, we got the 2D documentation, right? Just a waste of time, because we still contract a code and do the manual quantity takeoff and do the pricing. So it's a lot of waste of times and efforts. So they are going to switch to digital documentation, right? Okay, anyway, this technology study is a kind of is matter of the legal matters, right? How to phrase our contract document and so on, how to manage the contract disputes if we go to a digital format, right? That's a matter, but technology is there, we can do it. Okay. Okay, then model should be accurate, because I always say this is for the quantity takeoff purpose, right? So model should be coordinated and should be accurate, right? So it's not like the design model. It may be in geometry may not accurate, but because client going to see the uh, how it's going to look this building, that's all. But here your model should be ready for quantity takeoff, right? Then appropriate for sharing, collaborating, coordinating environment. That means your model should able to coordinate with other rates. And let's say you are building a special M&E services. So is a specialist M&E consultant want to supply some equipment to the model you are building. So if they have the concerns whether their equipment can fit into your building or not. Traditionally, what they do is they share all this information to architect, then architect do the design accordingly. But now there's a concern because some business, they have their own secrets, they have their own uh, protocol, they don't want to share some information, secret information, business secret information. So normally what they ask is, they ask us to share the models, right? So they do their own collaboration and see whether can able to fit inside our building or not. Then they give the quotation based on that information. So the BIM enable all these abilities. So we can collaborate, we can coordinate with all other vendors easily. Okay. Can be an essential tool for complex building. Okay. So our model should be ready to incorporate all these changes as easily. Okay, so this is just an example, the documentation of house look, right? So you can see here, okay, if you have steel connection, some steel connection, so you had the details, something like this. Okay, construction model, okay. So you can see the accuracy, right? Accuracy is paramount because it's going to be constructed, right? If you put this model, right, they are going to construct according to the model. So this your accuracy is paramount. It should be a perfect. Right? If there are issues, then you are going to get the same product. Okay. Then here in the construction model, 2D drawing is not the key priority because the contractor able to communicate the BIM modeling, right? They may not need to do the produce a 2D drawings. Okay, they are producing for the construction purpose. That means they are producing the sub drawing, but it's not necessary, right? The sub drawing, why they need the sub drawing? The site foreman or site engineer needs some document to verify. Only that purpose they produce a 2D drawing. Otherwise, they don't need because the model itself contain all information. Model itself explain all information. So no need 2D drawings. The purpose why you need the 2D drawing only the site. The site so far we don't have the digital the tablet or digital screen to see all this one, but in future maybe. But so far we are doing the 2D drawings. Okay. Okay, that's why what the difference between construction model and documentation model, right? The fundamental difference is how and why model is created, right? Okay, if consultant produce that called documentation model, if contractor produce that called construction model, is sometimes maybe same model, but just a different term only because of the different people use this model. That's it. Okay, this thing you want to understand. Construction design versus construction, right? So here you can see it is a one wall, right? One full wall from first story to third story, fourth story. It's a one wall. But can we build like this? Not possible, right? We know, right? They had to construct stage by stage, right? So that's why. Sorry. Okay. You see, if contractor produce a construction model, right? They introduce it intermediate levels because this wall anyway is supported by the slab, right? Then you can see the slab here. But to architect, right? To them there's no slab, right? The wall is just standing like this. So this is the major. This is a fundamental difference between design and construction model. I think now you understand, right? Okay, here you can say this word as a even documentation modeling, right? So now you can what you understand consultant versus contractor. So consultant model versus contractor model. This is a fundamental difference. right? So consultant model may not capture the construction sequence, right? Contractor model supposed to capture the construction sequence. Okay. Okay. Finally, it's a coordination model. Okay. Coordination model is main purpose is coordinate with different rates, right? How to coordinate with the different rates. That is a or by end of the day, you had to coordinate all rates and put in the one model, right? So that's called is a coordinated model. Okay. Okay, there's a okay, just process. I go through it, just read it, right? But in this stage, right, what we do is contractor normally take our document as a model, then they produce a construction model sometime, or sometimes they may not produce a construction model. So what they do is they start to coordinate the different rates and do the class direction, right? Is there any classes or not? Right. So sometimes our beams and MNEs may clash it. So sometimes our beam to floor headroom not sufficient. Architect may not think there's a beam, so they may not have enough headroom. So these are the classes we can direct earlier. So that's the purpose. We are had to coordinate all rates into one model. So end of the day, we can see like before construct, we can see. So now there's a different terminology people use, virtual construction modeling. We see a virtual construction modeling. Yeah. So before go to the actual construction, they do the virtual construction and see how it's look, right? So in the model, you can go inside and see how it's look, right? So it's like a virtual platform. So the same model, actually it's the same model. They export a different software and do the animation. That's all. There's no any magic, just a different animation. That's all. So you can measure your headroom, how much clear headroom you have it. Is there any classes, or if classes, how you can rearrange it and so on. So this virtual construction actually advanced version of the BIM modeling. Okay. Modeling and project phases. Okay, how we do the modeling based on the project phases. Okay, project, I already say there's a lot of phases, right? From initial to and to the end, there's a lot of phases. So how we do the modeling according to the process. Okay, this one is special terminology. Sorry. Building, design, process, and BIM model development process are linked, right? Think this link is built upon level of development concept. Okay. So this one called is level of development concept. So LOD, right? So sometimes, right, if you go to the internet, right, so people just do D only, right? They call 1D, 2D, 3D, 4D. It doesn't mean dimension, right? We may worry, right? Normally we know 3D, right? 3D. What is this 4 dimension, 5 dimension? No, it's not 5D like that. It's actually level of development. Later I go through what is the development. So it's a LOD, we call LOD. Some countries they use different terminologies, right? So the understanding this one, what's the level of your model? That's all, right? So they may use a different terminology. So these are the project phases, right? First one is a pre-design or briefing, right? So basically, client, right? Let's say building departments. We are building departments, right? They want to build 5-story office building, right? So in the tender briefing, they give, okay, we want 5-story building. The each story this amount of square meter. So this is a usage. We want the toilets and so on, this area and so on. So they had a brief. So based on this brief, architect, engineer come with the layouts, right? So this call is a briefing and conceptual design. So briefing means just a plain document, text document. It's not a drawing. Conceptual mean the plain document transfer to the SketchUp. It can be AutoCAD drawing or whatever, but basically it's a SketchUp, right? So we conceptualize that text. Okay, the text put a briefing. Then from the briefing, we understand the briefing and put in the drawing. This called a conceptual design drawing. After that, from the concept, so let's say the concept, our concept accept like client, right? Then we go to schematic. Schematic means, right? So we, okay, yeah, from in the conceptual drawing, right? It's just a layout. Even engineer no need to involve. It's just a layout. Architect keep allocate different usage in the building. That's all. The schematic in model schematic design only was normally contract engineer involved. So what engineer do is that time they decide what scheme, what structural scheme they supposed to use it. Okay, we have a lot of scheme, right? One-way beam slab, two-way beam slab, flat plates, portions and beams, and so on, right? So that stage engineer decide which scheme suitable for this building. Right. So foundation, shallow foundation or deep foundation. So engineer that stage they design. That's called schematic design, right? So still that's a geometry. It's not a detail, all right? So engineer design. Okay, I go with the one-way beam slab system superstructure, substructure. Okay, this soil condition not good, so I may need a deep foundation, file foundation, or file foundation. They had then need to design ribbon pile or bob pile or whatever, right? It depends the site condition and so on. So that scheme design. So basically schematic design, right? Really I explained, right? It's like a design model, right? Yeah, okay. This is a process, different phases. I explained the different phases. So each phases, whatever involved, I explained here. So the schematic stage, we develop the design model. That stage only we develop the design model. Before that, there's no modeling. It's just sketch only. From the schematic design, once our schematic setup say okay, then we go and develop the design, right? Our schemes are okay, accepted by client, then we start to develop the detailed design, right? In the detailed design part only we into in the structural analysis and design involved. Schematic stage, right? Generally, we don't do any analysis. Based on our experience and knowledge, we do the size up. Right. Generally, structural member size up, we don't use analysis. Generally, don't use unless structure is very complicated. Then we do this very simplified analysis, 2D analysis or simplified 3D analysis. We don't do the full modeling in the schematic stage because client may change their mind and they can change the design concept. So we don't do the modeling. Only detailed design stage we build up our structural model. They then do the detailed designs, right? Then contract documentation. Earlier, I already explained many times what is a contract documentation. Basically, it's a detailed design. We put in the documents, right? Okay. Then the construction, right? After contract awarded to the contractor, right? They start the construction. So then they do the own design methods, right? Finally, right after finish the construction, it's called post construction or facility management. Okay, after finish the construction, it's a big building. It's not a small building; it's a big building. It okay. It's let's say it's a multi-user. You can assume it's a shopping complex, right? It's a multi-user, right? So there's a one facility manager or building managers, right? So they supposed to manage this building, right? Because there's different users, right? So they had to actively manage this building, right? So building contain lot of services, fire compartments, fire alarm systems, or other M&E services and so on, right? So building owners or building managers should know each element where it's located, how to manage this one. So the BIM help them. So if they have a model, then they can visualize. Okay, if there are an issue, then they can call the contractor and say fix it. Okay, there's an issue, so they can easily fix it. Otherwise, they had to go physically and find out where the issues. It take a lot of time. So the first construction stage also this BIM help them. Okay. These are project phases. Okay, I think this one I can skip it because this standard Singapore thing. Okay, skip it first. Okay, LOD. Okay, LOD, level of development, right? So the level of development directly proportional to object data level or object information levels. I can put it this way. Level of development directly proportional to object information level, right? What do I say? What is object, right? So object contains the information, right? But what level of information we are giving at the stage, right? That's called is a LOD. I think now you clear it. What is LOD? Right? LOD, they may use different terminology in different countries, right? So that's why I put two different standard, US and Australia, right? In the US, they call 100, 200, 300. Singapore also, we are using this one, 100, 200, 300. But Australia, they use ABCD, right? But generally, the concept is same. All of us are concept is same. Level of detail, right? The particular object contain what level of detail? Example, column, right? So in the concept stage, the column may not have the sizes. So only we know there's a column. Like in the concept stage, they just know there's a column, but they don't know the column geometry. That means they don't know the sizes. In the 200 series, right? We put the sizes, right? We put the sizes, but there's no rebar anything, just the sizes only. But 300 series, we include the sizes. Normally we include the sizes, rebar sizes and so on. So it's like a documentation modeling, right? Then the 400 series is a fabrication. Okay, I can include the rebar sizes, but you're gonna fabricate like that, no? Rebar, you're familiar with the bar bending schedule, right? Bar bending schedule, right? So fabricant time, you have to produce that one, right? That information supposed to contain in the model. We no longer go and do the manual bar bending schedule. No, we are not doing. Right? In the BIM model itself produce a bar bending schedule. So we had to give the information, how to bend the rebars, what's the type of bar, what's the lab length, where to lab, and so on. We had include in the fabrication model. That's what we call as a 400 series model, right? Then it's as-built. As-built, okay, fabrication as-built different is the as-built model. Actually, it's a fabrication model, but it's combined together. Right? Fabrication model may be rate basis. Structural have one model, architect have one model, and so on. But as-built model is all collected together, all coordinated together and put as a one model. Okay, that's called as-built model. Okay, these are the differences, right? So next time when you go to the industries, when you work on the BIM, right, people usually talk about what level of your detail, what level of your model. Normally they talk about this 100, 200, 300 series, right? In Singapore, still we are working on the 300 series. We haven't gone to the 400, 500. Right, some countries they already start the 400 series. I don't know the 500 really, but for some countries they already start the 400 series, right? It's basically different is anybody can do that any level, but the purpose, whether it's uh, uh, useful or not, right? As a designer, right, we may not able to do all fabrication drawings, right? Fabrication level detail, right? Then that's when we supposed to leave it to contractors, right? So that's why I earlier explained it's a process, right? BIM is a continuous process. So start from architect, engineer, then contractor, finally go to the building manager. So it's a long process. Okay, now, okay, this just I am going to explain, okay, what is the meaning of 100, 200, 300. Again, this one basically is based on the Singapore standard, right? In Singapore, we are specifying like this, right? So if you ask me why, I don't know, I don't get the reasons. It's just a naming, just a standard, that's all, right? So in the 100 series model, if you say our model is 100 series, then people know, okay, this model is just a volume areas. The model may not have accurate geometry, right? So it's not suitable for detailed quantity takeoff. It's only suitable for high level quantitative. Like sometimes, when we do the cost comparison, right? If you know the cost based on the meter square. Let's say I had to build a building, so I know per meter square how much cost, then I can calculate it. But if you want to calculate based on the concrete quantity or actual rebar quantity, this model may not be useful, right? So this model purpose is just rough geometry and it's a conceptual model, right? So it's not suitable for detailed cost analysis. Okay, so that's why I put planning activity, concept development, non-geometric, briefing data or line work, area, volume, so on, etc. Block model is it's not a detailed object based, it's a block model. Conceptual cost allowance, you can do it, conceptual, but it's not a detail. total project cost or due phasing of elements, you may be able to do it, but it's not detailed. Then environment requirement. Okay, if you have any environment concern, then you can do it here because you already have the volumes, you already have the boundary of the building, so you can do it. Okay, the 200 series, here we start to develop from 100 series. So we are going to accurately model our geometry. So column means we are going to model in column size, beam size, and so on, right? So here we are going to do the detail modeling. Okay, so generic object in visualization of concept model to allow for digital prototyping. Generic elements shown 3D dimensions with maximum size, assume system types. Preliminary time scale order for appearance of major activities. So it's basically time share project timing. So based on the, okay, let's say for piling or foundation, how much timing, superstructure, how much timing, architect work, how much timing, final users, we can know how much timing, so on we can do from here. We cannot do the macro programming in the construction those familiar with the construction side, right? You know how to schedule your program, right? First story concreting, how long? Second story concrete, how long, right? This one, in this model, you may not be able to do it, but the overall programming, you may be able to do it, right? Okay, here again, the estimation is based on the generic information, right? It's not the specific information because information not sufficient. You don't have the rebar detail and so on. Okay, so here you specify you allocate the locations for the different usage. Okay, you can take our approximate quantity of material for preliminary environment analysis. Okay, the LOD 300. Okay, so this is a maximum level in Singapore consultant doing so far, right? So in this level, we are putting all rebar details. So 100 series is a concept, 200 series we further develop. So you can see the geometry. 300 series is equivalent to our tender documentation modeling, equivalent to documentation 300 series in Singapore terms. Other countries may have different. Okay, so in this terms, in this my LOD, right? So we do the detail. So so that means it's ready for tender. So we do all detail. So we can do the project program, everything in details here. Okay. Give me a minute. Okay. I think I don't want to go through all this information. You can read it. Okay. Basically, I believe you guys understand what's the meaning of LOD 300. I already explained many times what are details including the 300. Okay, for the series again is the fabrication levels, right? So as I said earlier, in the fabrication, right, I took the example of column, right, column or beams, right? So if you put the information, rebar informations and bar as lapping detail and so on, right, then we can able to produce a bar bending schedule from this beam model. So that level of detail can be included in LOD 300 fabrication level, but it's not in the for 300 series. 300 series you can understand, right? So there's no just a rebar only, right? So there's no any lapping detail, there's no any bend rebar bend detail and so on. Just bar, that's all. Okay. So sometimes contractor they can include the construction method, construction process, and so on. Okay. Okay, 500 series is a as-built model, mainly for the facility managers, right? They keep the records, right? So basically what they want is normally the as-built model, the purpose is mainly two purpose. First one is maintain the M&E, mechanical and electrical, right? Maintaining the electrical and mechanical services, right? So this model can, let's say once one area electric power out, right? Then they can go back and see the design. Okay, which area should located. Then they can go and repair it. So that's the main actual purpose of this model for facility manager. Secondly, is a ANA. Right? If you want to do any alteration in the building, structural alteration, then you already have the all information, right? Then you can see the requirements, right? Whether you can able to do the alteration or not, right? Sometimes if you want to use a change of use, right? If you want to change the use, right? Then you can check the loading, whether the original design already have the allowance for this loading or not. So if you don't have the allowance, then you can decide whether you want to do the strengthening or not. So this all information already you have it, then you can your work is easy. Otherwise, you had to go to the site, you had to do the site investigation, find out that may not be accurate, right? You had to raise a rebar, you had to raise a concrete strength, and so on. Is costly and may not accurate. But if you have the information in the building owner side, then you can easily use that one, right? That's the purpose of LOD 500 models. Okay, these are the advanced technologies, right? So I already say, right, people are, okay, now they are talking about the 7D and so on, right? I'm not familiar, but okay. Basically the D's means, right, it's different, different roles. I can say different roles, right? When uh, consultant has a role, we call 3D. When contractor involved, we call 4D. When facility manager involved, we call 5D, right? Then they take advanced level. Okay, if you want to demolish this building, say they call life cycle analysis. So for that analysis, they call 560 and so on, right? So this basically is a model, is the same models, but they adding the more information, because that's why that's the beauty of this technology. We already have a object. So on the particular object, you can keep on adding your own informations. Let's say one example. Okay, column. Okay, today I do the column, right? I have no knowledge of carbon footprint, right? I have no knowledge of the carbon. As engineer, I have no knowledge in the carbon footprint. So I specify, okay, grade for this column supposed to be cast by grade 40 concrete. So contractor bill accordingly. So 5 years later or 10 years later, client want to know how much CO2 emit by this building. So how to quantify this one? Then this model is useful because they already have the information, right? So what they want to input is, okay, grade for the concrete, how much carbon emitting rate. They just input that parameter because they already know the volume. They already know the surface area. Then if they put the emitting rate, right, then they can find the answer. Right. So this they increase the number of D, right? That means they can take into advanced analysis using this information. That's in the D keep on increasing, right? But there's no other different. You don't think there's a technology are improving. You had to learn those. Okay, no. If you learn BIM, basic BIM technology, then you can keep on adding this one. This is additional layers of information. That's all, right? So what you want to keep in mind is we have objects. When we build it, we have certain information only. But later on, you can add more information. Also, you can extract my information and you can do the bad calculation using my information. All this information serve in one particular file. That's the beauty. We have in a one file, all information is computable. Machine can understand. We don't need a human. So machine able to understand all information, right? Yeah. So yes, I go to the advanced technology. What are the advanced technology people are using it? May be useful for you. Okay, 4D and 5D modeling for optimization, right? So this one you can understand easy, right? So sometime engineers design, architect design, people see is also over design. They had to do the optimization or value engineering. So how to do it, right? So how to find out whether reduce, okay, sometimes you say reduce the quantity may not value for money, no, right? Because if you can reduce a quantity, but your construction method may be costly, right? It's maybe take long time. So how to do this analysis? Then this model will come to play, right? Because before reduce the member sizes, you know the quantities. You can calculate how much formwork area and so on. After reduce the quantity, right? You can calculate the formwork area and so on, quantity and so on, right? Then you can do the comparison, right? Concrete volume reduce it, but formwork area increase. Formwork cost is costly. Then why you need to go for this one? It's not value for money. But if in the blank, right, it may look like a economical design because quantity less. But end of the day, in the cost point of view, it's not value for money because you are spending more money or almost equal money. Then why need to waste the time? So if you have all this information in the model, you can do the analysis fast. Okay, facility manager. I already explained how useful for this facility manager. Then rule-based design. Okay, this is the things, right? We are going to do it. This model, we take it to another platform and do the design. Okay, okay. Sustainability, LCA, and use of eco profiling. I already say, okay, if you want to do the sustainability analysis, if you know the material, the parameters, right, like a carbon emitting rate, and so on, right? So if you know this information, you can input it and you can do the analysis. It's faster. Bill of quantity and specification, right? So nowadays, in Singapore, we are using we are taking a concrete volume. So in Singapore, one thing we normally calculate meter cube per meter square. How much meter cube of concrete used for meter square per meter square? That's just a case to level our concrete usage index. Okay, so normally we don't go more than 0.4. That means 0.4 meter cube per meter square. Right. So you see in the traditional drawing, right? How long it take to calculate everything? We had include not only structural things, no, we had include architects of walls and so on. How long it take to do the calculation? Then we may able to make human mistakes. But if in the model, right, it's one click. Actually, so with one click, you can find out all things. Right. So day to day in our project, we are doing this one, the quantity takeoff, very fast. We haven't go into the rebar quantity takeoff yet, but concrete quantity takeoff very common. We are doing very commonly. So we know the concrete usage index. How because we don't want to overuse of concrete. So we know this, so we can catch our building. Okay, so if go more than 0.4, then we find the reason why we are going more in 0.4. Can we reduce it or not? So it's advanced warning sign. So we can go back and see our success scheme and find out the reason to why our concrete sizes are big. Okay, so these models are useful for that purpose. New business approach, lean constructions. Okay, again, it's like an optimization, right? So new business. Okay, it's how I can say is okay. Now you have a model. One person build the model, but another consultant, they say consultant, they have opinion. They can optimize the design, but they can start from beginning. So they can use this model to do the optimization. That part only they do it. So we can share this model so they can do that information only. Then increasing offsite fabrication. I think this one not common in Sri Lanka. Prefabrications, that means precast and steel, but it's very common in Singapore. So mostly we go with precast. We don't use much cast in steel. So if you have model, then it's very useful. They can do the all. They can make use of it because earlier, right, before we got the BIM, right, about like precast fabricated, they do their own drawings. They do own fabrication drawing. Now their life is easy. They can make use of our drawing and produce a final fabrication drawing. They don't need to do the intermediate drawing. So intermediate drawings is there. Okay. Then model servers. Okay. Model server, the useful, another useful, right, is create useful. I can say create useful, right? One model, right, can be run by any numbers of people. Right. Earlier I said it's a geometrically coordinated object, right? So let's say I had a 50-story building, right? So my team, I have 5 raptors, 5 BIM modelers. I call 5 BIM modelers, right? So I divide the works. Okay, person 1 responsible for first 10 story, person 2 responsible for and so on, right? So I divide the work. They can do their own computer. They can do it, but it's okay. Normally, what we call is center file, right? So normally, what we do is we set up one center file in the server, right? So this center file contains the information of the each 5 people, right? So they do their own works. Finally, we bind together and make as a one model, right? So it's a very easy work. You just click one button, you can make it as a one model, right? The reason is coordinated, geometrically coordinated. Each point has its own coordination. It's a global coordination. It's not local coordination. It's a global coordination. In Singapore, after we do the surveying, right, site surveying, right, we can include our topo into the model. Then it's contain the global coordinate system. Actually, you can put in the Google map. It's that precision, right? So each point contain the global coordinate. Then you can merge together, or you can bind together as a merge, make as a one model. Okay, so almost we come to the end. Okay, so this is a purpose. Okay, client, he is our master, right? So he had to communicate with all people, right? These are main party or main stakeholder involved in the one of the projects. Normally we have all these 5 parties, right? Developer, he is a building owner, right? He engage the architect, he engage the structural engineer, he engage the M&E engineer, or finally he engage the builder to build this building, right? So one model, okay, let's say in the client has a one model, like let's say, I assume, oh, it's let's say a server, right? All independent consultants, they have their own system, but all the information are stored here in the central server. The central server can know architect what information they have, here what information they have, M&E what information they have, builder what information they have. Independently, they can work their own model. They don't need to ask this guy. They can work on their own model. Finally, they can bring to a central model and bind together. So it's become a one whole model, right? So in individually within the organization, also you can divide it in the big level, the rate to rate, or a consultant to consultant, you can coordinate together. So that's why the Autodesk Revit, they have one cloud platform they call BIM 360. So it is a cloud-based collaboration platform. So if we actually we need the license. If we have the license, we can upload our model in the cloud platform, right? We can anytime we can upload and we can download it. So normally we don't share the model through the emails or Google Drive and so on. So normally we write to upload the cloud, then a respective consultant know, okay, this is a model. So they collaborate it. So they don't need to download. Actually, they collaborate and they bind together and see if there are any changes or not. Right. So that's the purpose. Okay. Now I got some digital format involved in BIM. Okay. Okay. These mostly are additional things. Okay. Advancing I come later. Okay. If you want to link to application, because the applications are developed by individual vendors, right? They have their own technologies, right? They may not able to share between other companies, right? They may not share their business secret to others, right? So there are some common formats, right? So how to link these two, right? So it's like how to say, okay, take a database, right? A database, right? Database, right? So if you create a database, you can communicate with this database from any of the software. I call as a computer program. Okay, I have the SQL database, or I have the Access database. You can use any sort of computer program to manipulate or extract this data, right? Similarly, to link between two applications, there are some format, right? This ODBC is very common. I'm not familiar with this one. ODBC very common, right? Let's say Excel example, right? Excel you can open in Google Sheet, right? The reason is they enable this technology ODBC, so you can use other platforms. So the general, okay, the particular Excel developers, they enable these technologies, so Google Sheet can understand their format. Otherwise, they cannot. This one I know. Others I actually am not familiar. Right. Okay, geometry format. We know the DWG, right? Someone, I think DXF also know. Okay, this one also similar, but different is but this one only read by Autodesk, but this one can be read by many other softwares. DXF. It's like a common format, but it's not it's not able to understand by all software, but it's almost most of the software can able to understand DXF. RVT is a Revit part they call RVT, right? Then DGN is I think DGN used by Bentley Metro Station. It is a SketchUp, Google SketchUp. 3DM, I'm not sure. This one I'm not sure. Okay, the problem is these files are great, they're intelligent. But problem is if you want to use other platform, you may not able to. Right? You may not be able to you can export it sometime, but you may lose some information. You may lose some features. So avoid this problem or overcome the issue. International committee, this called as a I forgot the committee name. It's like ISO standard committee. They come with a file format called IFC, International Foundation Classes. Okay. This is a common file format like PDF, right? So all Revit, all BIM software are supposed to enable this IFC format. So once you finish the modeling, you should able to export as IFC or you should be able to serve as IFC file. Okay, once you serve as IFC file, right? You can call any other BIM software to open it, or you can call any other IFC enabled software like ETABS. SAP 2000, Tekla Success Designer, or other software is SAP Pro. You can open it, right? So also you can manipulate it. You can edit the information. That's the beauty of IFC. It's open, exchangeable information, right? Another thing is now many countries. Okay, IFC is an international standard. So vendors they have to satisfy the standard. On top of this one, right, some countries they are putting another layers, I can say layers, right? Say example Singapore, they call IFC SG, right? So we have to produce our documents in IFC SG format, right? That means we had to satisfy Singapore drafting standard. They had a standard, so we had to satisfy it. So that make sure that this file is served in IFC SG format. Okay, what's the difference between IFC and IFC format? Okay, main challenge is IFC, right? Okay, later I explain when you go to Revit, right? And the object, right? Sometimes we use a standard object. Sometimes we may need to use custom object. We had to customize it, right? When you do the customize, right, it's depend on the users, right? Users may not, user lazy, they don't want to do the more detail, right? They just do the fundamental detail, right? Then the IFC, right, may not able to understand because some software vendor want to give more flexibility for users, right? So they normally allowed to produce a custom object only for understandable by their platform. It's not IFC format, right? So that's why some custom object may not able to read by IFC, other IFC format readers. So that's why some countries, including Singapore, they are producing their own standard and say, no, if you want to submit to our authority, then you must comply IFC SG format, our standard. You must comply. Whether it's a custom or standardized format, you must comply. So when you produce your own custom families or custom object, right? you must satisfy it. You must satisfy their standard, right? So it's very interesting because you see, as engineers, right? Now sometimes I feel problem. Okay, I do the modeling ETABS, right? But I want to open the other software. Okay, because you know these softwares are very expensive, right? So super expensive, right? So the small company cannot afford to buy many license, right? Normally we buy one or two license, right? So when all licenses are occupied, right? If you want to use for others or other for software, right? I can open it. I have to wait until my colleague to finish the work. Right? It's just wasting my time. So I have to depend on these softwares, right? So, but if we have a command format, right, all software are supposed to uh, comply the standards, right? Then our life is easy, no? We don't need to depend on all these softwares, right? If we, let's say I model in TechClass exam, tomorrow I can open in ETABS. Okay, running and results is different story, but I can open the model, right? So that's the important. But unfortunately, none of the software, success software, they enable IFC. But BIM, they must, because authority they bring the requirement, they must enable IFC. So we must submit IFC format. We cannot no longer submit RVT format or DWG format. We have to submit IFC format. That's it. All digital file supposed to be IFC format, right? Then you don't need to worry about any software problem, right? It can be read by any IFC readers. Okay, finally, XML base. Okay, I don't want to go in detail. XML is right. So those familiar with computer programming know this XML, but it's a very long one. I think I don't want to explain too much. XML is a one of the file format. All right. Now people are thinking to bring IFC XML. Actually, right, IFC SG Singapore, SG is kind of a IFC XML. Okay, it's one kind of XML is a very general term. Any countries or any companies, right? They can produce their own naming using this XML standard. XML is a common standard. Anybody can use it. So if you produce your own standard, you can put your own name, IFC, whatever name, right? So that's XML. XML is just one file format. Okay, but if you go to if you ask some of your computer friends, right, then they can explain more in detail how useful is XML. Okay. Okay. So almost we come to the end. So I'm going to introduce software. Okay, BIM software. There's so many softwares, right? We had TechClass Success, we had Revit, Bentley, Autodesk, Success Detailing, Robot, Pro Steel, and so on. Okay, so as I said earlier, in this course, I am going to use Revit Success, right? Revit Success. But all this software I almost have the equivalent capability, especially Tekla. I use a Tekla, quite good software for the steel modeling, steel fabrication. Very, very nice software for steel. Even Revit, we don't have a lot of tool for steel design, steel detailing. But Tekla, they have plenty of tools for the steel modeling. I'm not familiar with. Okay, Autodesk. Okay, why I choose the Autodesk is a very simple. I'm family AutoCAD, that's why I use Autodesk Revit. Okay, also my company has a license, so that's why I choose Autodesk. There's no any other reason. Okay, okay. If you're engineer, if you ask me, I prefer TechClass Success because TechClass Success is simple to use, easy to learn. Revit actually is quite complex compared to TechClass Success. But unfortunately, our office, we don't have a TechClass Success license at this moment. Earlier we had, we don't have. So that's why I skip it. Okay, that's no other reason. But as an engineer, I like the TechClass Success. Okay, the Revit. The good thing, okay, already I explained BIM, right? So now we see in the Revit how they implement all these BIM. BIM is a technology, how they implement it. Okay, Revit is a object-based modeling. So they comply the BIM standard. Okay, BIM also object-based modeling. allow for easy extraction of object information. So we can extract the object information. That's a basic soul of the BIM technology. So the object you define the object, you can extract the information object. Okay. Then live model based on coordinated documentation. Like this live model. I already say one LOD, 100, 200, 300 is a live model, right? So Revit has this capability. We can keep on update this one. One model for multiple users, right? But I already explained, in the central model, right? We can set up one central model, so any numbers of users can use the same model. They can work on their own independent rate, but it's a one central model. Okay, it can be exported to 2D or 3D IFC or what other formats. Easily it can be exported, right? It has some, then the Revit captions some rendering capability. If we like to do nice architecture rendering, then there's a capability to do it, right? But it's not good like sketch 3D Max and so on, but there's some basic capability, right? Okay. Incurrent access to parametric modeling. Okay, this is important. Last one is important. Incurrent access to parametric modeling. So it allows the parametric modeling. So the object we can create our own parameters. Okay, the particular object already has a typical parameter. We can give our own parameter. Let's say, okay, no, column. I take the example column. Okay, this time I take the example other elements. Let me think. Okay, steel beam. Okay, vertical steel beam is a customized steel beam. Okay. So let's say castellated beam. So castellated beam, trapezoidal opening, right? At the center we have a trapezoidal opening, right? So I give the information on the model. Okay, what is the area of the opening? Each opening, what's the area, right? After we finish the model, right? I like to know how much steel cost I can serve from this opening. Because I want to do the comparison studies of castellated beam and steel beam. How much is cost serving? Because steel beam is maybe more weight, but production cost less. Castellated beam maybe less weight, but production cost is more. Now I want to do the cost comparison. Which one is cheaper for this particular building? So if I give this particular information to the model, right, then model can give the total quantity is one click. You don't need to go back and calculate each and every beam. It's one click. The one you can print the table. At the end of the table, you can see the sum. How much is total actual quantity, right? That's the things we want it. That's why we want this BIM technology. So model, whatever information we give the model, it can be extractable. It can be manipulated. It can be exported to any other platforms. Right? Okay, that's the advantage of this model. Okay, so this is my end of part. Okay, from next class onwards, I am going to start software. So for this software course, right? Basically, you have to install two software, and third one is integrator. Okay, Autodesk Revit 2023. I'm going to use it latest version. And 2024 they may be, but I know I'm going to use the 2023. Better you install 2023. Tekla Structural Designer, I'm going to use 2022. They don't have 2023 yet. Okay, so this software, Tekla Structural Designer, right? If you go there, I saw you in Google. If you go their website, right, they allow to install 45 days trial. So if you install now, my class ending 8 weeks later, right? So last week you may not have access. So you may if you want, you can wait 1 week later, then you can start install this one, right? Revit actually they allow 30 days only. This is a problem. I don't know how to manage. Really, I don't know how to manage it. Revit. Okay. If you want, you can wait for a while and install later on also can. Okay, so the installation sequence, first you install the Autodesk Revit, then you install the Tekla Structure Designer. Third one, you look for this Tekla Structure Designer integrator for Revit, right? There's a similar software. So this one means after install this, it's not an independent software. After install this software, right? Inside the Revit, you can see this integrator tool. So you just using this integrator tool, you can export the Tekla Structure Designer easier. Otherwise, you can export the IFC, then you can import. So this is a two-way process. This is just a one way. So in one click, you can export a Tekla Structure Designer. Then easy. If you want import also, you can import to Tekla Revit through this integrator. Okay. So now I export to the software. Now you can see my screen. Okay, you can see this one, tekla.com, www.tekla.com. So you click this one. They allow start free trial 45 days. So just click and install. I cannot do it. I have a license. Okay, I should not do this one. Okay, so you can install. Similarly, I think Revit, some of you familiar because you familiar with Autodesk, right? You install a student version. Okay, you install this Revit. Okay. Okay. So after install these two software, then you open the Revit. Revit. I just opened the existing project. Anyway, you can just start a new one, no problem. Yes, I want to show you what you want to do. Okay, here you can see Tekla integrator because I already done it, right? Okay, what you can do is, okay, Tekla integrator actually you can download separately also. I think that's easy, right? Tekla Sakura integrator for Sakura designer integrate with Revit. Okay, here link to download. Okay, download and install it. Okay, after you install it, right, here you can see there's a one menu called Tekla integrator, right? So here from using here we can export it. Okay, another way, right? Okay, I think this is not preferred one. You do it that way. Okay, first want to install eTabs, right? eTabs, right? Then you go to the App Store, Autodesk App Store. Right. So here, okay, change Revit, and here look for CSI. 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 Just search CSI. Okay, CSI link. Okay, install this one. Okay, okay. If you click, it's explained to you what is this one. CSI links the external application portal to enable user to transfer analytic model from Revit to CSI safe and CSI test analysis, right? So I think CSI link is free. This one is the paid one. We don't need this one. So only thing you have to see export link. Okay, later we know what is this one. Is export link and the design sheet. Those things we cannot do it. Others we can do it. Okay, so those who want to do the want to use the ETAP, install this one. Others install Tekla Success Designer and Integrator. Okay, I think that's all today. Sahara? Okay, I allow all of you to unmute now. If you want someone, all of you unmute. Unmute yourself. Okay, if all of you unmute, at the time it's very hard to listen, but one by one you can ask if you have any doubts or if it is speed or if it is slow, whatever, if you want, you can communicate. Also, I think we want to discuss about the timing, right, Sehran? You can unmute yourself now.
Hello.
Hello, yeah. I think we want to discuss about the timing, right? Can we change the time?
Can we discuss through the WhatsApp group, no?
Do you want to do that?
These
Okay,
things.
fine. No problem. Okay, fine. Okay. Then anyone want to ask any questions? Then you can ask. You may ask one by one. Okay, I want to know because first time I'm doing it, so I want to know whether it's like it's look speed or it's look slow. I want your opinion. So if it is very speed, okay, today maybe it's speed because it's just a theory part. I want to cover. I don't want to spend a lot of time on theory part. I want to go to software. But when I go to software, if you speed, then you can stop me. Then I try to reduce it. But you have to understand the time frame, right? This is the 8 weeks, 16 days, 16 classes. I got to, my schedule, right? So I because I don't want to keep half-baked product. So I try to give at least one building. So you should know how to start from beginning to end, how this process are going on. Okay. Yeah, I don't say this is a full real world. It's not. Okay. Real world, one building per design works for maybe 2 years. Right? It's a many process. I would explain the process, right? But at least you can get the idea how the design industry is working, right? So at least you know how to do the detailed design. Okay, upfront parts, yes, or normally senior engineers can do it. At least downstream parts, how to do the detailed design, how to do the documentation. At least you can get the knowledge on this one. So that's why I'm going to cover the full building, right? So anyone have any question? I saw many people are joining very late. I don't know what's the purpose of join very late. Right to be on time, or at least 10 minutes, 5 minutes, 10 minutes later, okay. But if you are join 1 hour, 2 hours, 1 hour later, I don't think it's effective, right? So next time, at least be on time. Okay, if we have no questions, right, we can end up this class now. So I think that time, as Sir said, we can discuss about the timing in the WhatsApp group, right? Okay, because you know now in Singapore, my time is 10:30. It's very late. Okay, I actually suggest to bring to 5 o'clock instead of 6 o'clock, so you can discuss your own opinion. I know it's maybe early for somebody because all of you are working. Maybe very early, so you may not reach your home. I understand your problems. But if most of you agree, then let's start 5 o'clock. Okay. Or by another thing, sir, and say one class may be shift to Saturday. Okay. Let's discuss your opinion, own opinion. Yeah, I think maybe tomorrow or before next class we take the decision. Okay. Sahar, anything you want to add?
Thank you.
Okay, thanks so much. See you next class.
Okay, thank you.